Hi friends, today I am here to speak about my research topic, the design or optimal size of the battery to achieve combined technical and economical benefits of a PV-BS system. The relevance of my topic comes when we want to determine the optimum capacity of the battery energy storage system and to minimize the levelized cost of electricity and to find the technical and economical feasibility of such a BS system in the market. The energy demand in the developing countries is expected to increase in the coming years. The energy demand is expected to grow about 35% due to the world population expansion. The fossil fuels still have the main incidence on the energy sector, even if their price volatility and their relevant environmental impacts are encouraging the spread of renewable energy sources. The renewable energy source already play a major role in several developing countries. They offer a great potential for the PV market, especially for the grid connected as a solution for the large diffusion of off-grid applications. The PV technology is one of the most suitable areas to switch the electricity generation from a few centralized facilities to a wide set of small, decentralized and distributed systems, thus reducing the environmental impact and increasing the energy fluctuation in remote areas. The prices of the PV components, for example the modules, the conversion devices, are rapidly decreasing, which will make the PV system and the BVS system competitive in the energy market. Battery energy storage. Battery energy storage can be used to regulate the voltage fluctuations to avoid intermittency in the power production and provide uninterrupted supply of power whenever required. Several studies are conducted to evaluate the integration of PVBS to the PV system, the effectiveness of PV system for a sustainable development, the need of optimization technique to optimize the battery parameters are studied in several literatures. Also, the cost analysis are discussed in certain literatures. To conclude, that the BV system is an important part, and also the optimal size of BV system is important to achieve the full benefit of a PVBS system. In several research, experiments are done on the technical feasibility of the PVBS system, but a few papers consider the cost analysis of the battery. Thus, to find the design of BVS system to achieve technical and economical benefits, we require a new model idea. Thus, it provides an opportunity to explore the technical and economical design of the BVS system and to implement the design to minimize the levelized cost of electricity. And it also provides a path for cost analysis of the system. The demand for energy of our system is fulfilled by PVBS system. Input of our system are energy demand profile, the temperature effect, the irradiation levels of the whole lifetime of a system in a particular area where the system is located. These data are analyzed hourly within a complete year which is under reference. This analysis helps to calculate the reliable power size of the PV system and system capacity of a BVS in order to reduce the levelized costs of electricity. Different analysis methods are used to minimize the levelized cost of electricity and also to make it technically profitable. Objective of our model is to fulfill the energy requirement hourly with the help of PV modules, energy and stored energy in BVS system along with energy conversion devices. Operation of PV system to attain energy demand can be explained as follows. Like, if there exists a surplus energy, the energy is directed to the BV system till its maximum charging capacity is attained, like the state of the charge. During the energy defect condition, the battery supplies the stored energy till it reaches the minimum capacity, that's the state of the charge. Analytical model is used to determine the capacity of BE system, which are changed into defined values to estimate the perfect configuration of the entire system. In this model, the BE system, the performance criteria can be represented by the considering the amount of hour where the battery's nominal capacity, the autonomy hour, the temperature and efficiency is considered. The above criteria depends directly on the depth of the charge, efficiency of the inverter, state of the charge, and inversely proportional to the energy demand. The battery capacity is also affected by temperature. The capacity decreases in low temperature, and with increase in temperature, the discharge and aging may increase. The BS stop charges when the maximum SOC is reached and the energy production and the demand is equal. Similarly, the system can provide energy when required until it reaches the minimum limit. The economic affordability of the system can be assessed by the lifetime study of AND LCOE, that is, levelized cost of electricity. It represents the price of supplied energy that is a balance between cost and revenue. It also helps in economic comparability of the several power generation methods. And the objective is to minimize the cost at the same time achieve the energy demand. The installation cost, the PV module cost, the cost of inverter are rated in PV power functions. The cost of charge controller and the battery bank are directly linked to the input current and the capacity of the battery. In order to stop decrease in performance and failure, components should have a replace and several activities for maintenance are required. Those additional charges are also considered. Additional energy from grid also increases the cost, while energy exchange or sold to the grid equal to the electricity market cost. Thus, the proposed method can be implemented. Also, the proposed method can be implemented in the Microsoft Visual Basics. And thus, combining the technical and economical design, we can provide a BS system which will be helpful in determining the effective design of a BS system. Thank you.